And for this reason, we start a little bit later this morning, but I hope that everybody could enjoy so far this fantastic conference. My name is Markus Rupp, and I have the pleasure to introduce the plenary speaker of this morning. His name is Raymond Knopp, and he's from Eurocom in Sofia Antipoli. And Raymond is a child of Eurocom, you could say, because for more than 20 years he works with Eurocom, and he was even the first of the students who received the PhD in collaboration with EPFL. And then he remained there, and he started into a field that some of the signal processing people would not consider signal processing because it's very practical. He gained a lot of experience over the years in building signal processing platforms, and in particular for communications, and made it possible that they are so flexible that a lot of people all over the world are using them, and that even gave him more experience in this field. And I think it will be quite interesting to hear from himself what all came out of this big endeavor. So Raymond, please come up to the floor.
It's coming now, I think. Okay. Yes, it's coming. Okay, thank you. Okay, so thank you very much, Marcus, for the kind introduction. Let me start by thanking the organizers. This is a wonderful event, a very wonderful city. I'm very happy to finally say I come to Galicia. I've been to Spain. I've visited many other regions in Spain, but this is the first time I come to Galicia, and I think I'll have to come back because it looks like a very wonderful place to spend some time with your family. I'd also like to thank Marius for suggesting that I give this presentation here today. I think it's fitting that it comes after the social event. Because it's a non-technical presentation in some sense. It's a little bit technical, but definitely not mathematically oriented. So I think it's a good way to get back into the technical program. So I'm going to talk a little bit about the road that we've taken, more or less over as Marcus said, more or less over the last 20 years. I mean, I promised to Marius that I would talk about open air interface, and of course I will. But I want to lead up to that a little bit, and give also some opinions that are my opinions on the links between academic research, standardization, and also prototyping. Okay, because as Marcus said, some people would not consider this kind of stuff as signal processing, and I tend to agree. Actually, it's not really signal processing; it's an instantiation of how you might implement signal processing on to build systems, which is very valid. In fact, that's what most of our industry partners are interested in, and there are lots of hard problems in this. So I'm going to talk about our adventure in this area. Let me skip that. So what I'm going to do is start with some lessons that we've learned from past mistakes. I think it's always good to look back after a long time and see what you did wrong. And if we look at those lessons and now look maybe for opportunities of how we as researchers, or some small subset of research in a community like this one, could benefit or make their work benefit 5G standardization, for instance, or let's say 6G standardization. Okay, if people are looking a little bit more ahead. And in particular, things that are related to signal processing. When it comes to signal processing or communication systems, communication theory, and the 5G or the 6G or even the 4G world, the hard problems in standardization actually come from the lower layers. They come from the people that are working on the physical layer processing. The majority of the hard problems, I think if you asked any of the major industry players, that's where most of the intellectual property lies. Okay, so communities like this one are actually fundamentally important for the industries that are making these things. And unfortunately, it's a very one-way communication link. They see all the work that we're doing in these communities. They're able to shape it so that they can build the systems, but they don't give very much back to these communities. Some of us do get funding from, occasionally, some small amounts of funding from these big companies, but to a very large extent, they are exploiting these communities. And those are some of the lessons that I've been learning. And you know, as an academic, I'd like to try and change some of those things so that we can actually benefit a little bit ourselves. In particular, when it comes to the, let's say, the intellectual property heavy components of these systems, which are related to signal processing. I'll also talk about open source prototyping, because this is one of the avenues where potentially we can take the work that's coming from a community like this and bringing it much closer to the tools that major industry is using. And that will lead into this initiative that I'll talk about, Open Air Interface. So what lessons you know, have I learned, at least, in academic research? Number one, you think very carefully before publishing a research paper with a section entitled Practical Considerations. You think very, very carefully before writing that section in a paper. Or phrases like, imagine now a signaling scheme where, very dangerous words today. Unless you have a patent behind them, very dangerous words. And sometimes you get carried away and quickly publish results that are actually pertinent to the real systems. And this could be extremely costly for your research institutes. It's very good for your academic reputation. You know, if you have a paper that you know, that it very clearly has some practical embodiments that could go into systems, could be very good for your academic reputation. But it could be extremely, extremely bad for your institute's budget. Okay? Some of the mistakes that we made in the past, I think right now would make the director of Eurocom cringe. I don't say this too loud to him, but you know, I think he would not be very happy. You know, as a general rule, as an academic institution, if you're working on something that is basically a receiver algorithm, okay, in general there, I think there's no problem. You can publish whatever you want as fast as you want. I really don't think there's anything necessarily monetizable in a receiver algorithm today. However, if it's a transmission scheme or a signaling mechanism, that's where you have to be extremely careful. Okay? We did get burned on these things. And I took an example here from a paper that was written in 1995. There were a series of papers. And this is one of these sentences here that can hurt. I mean, we can look at this as an OFDM system with one user per carrier and dynamic allocation of the users on the carriers based on the instantaneous frequency responses of users in each subband. That sentence basically tells you how to design a transmission system. This was in 1995. There were no OFDM-based cellular systems. And I think if you looked at the standardization in around 2005, you will see that at the beginning of 4G standardization, this is precisely what they put in the standard. And there are 3 or 4 examples in the work at the time that we had done related to the signaling strategies you know, that pertain to this hypothetical system, you know, and I think if you look at the details of 4G, you will find those things in there. Okay. Now, I mean, these results at the time were published. They were very good for our academic reputation. But you know, now when I look back, I said, how could we have written those words like that, or how could we not have thought that this kind of stuff should be protected in some way? We were extremely naive, and you know, I think this still happens a lot, and maybe people don't even realize it. Companies know how to publish papers after they've properly protected the essential ideas, but these things are very dangerous. So the natural question, I mean, if now as academics we start thinking along these lines that maybe we should somehow protect what we're doing, or find the, you know, if we think that there is something that is that could be essential to a future system, how do we go about doing that? Or why should we try and do that, first of all? You know, from my perspective, I think the first reason that why some of us, at least, should get involved is because I think the great majority of our PhD students today will not get academic jobs. They will end up going to work in companies to produce these kind of ideas. And you know, to a certain extent, I think it's healthy for a research organization to understand what their future students are going to be doing, so that could maybe guide them a little bit better. Certainly not all of the students, the ones that are very clearly going to go into an academic, towards an academic career, that's something different. But those that are almost certain to not, and are still doing a PhD in our labs, I think it would be a good service also to, you know, to provide them some initial information. So training in the actual process of the standardization, in particular when it comes to cellular communications, the 3GPP standardization process, and how to manage your intellectual property inside of a research, these are valuable things. And you know, I think it's useful not only for the future PhD students, but anybody that's working in the lab that is more or less sensitive to what's going on in industry. Another reason, I think, is that, you know, if a research lab has a few essential patents, one essential patent even, to a system, that could seriously help the research funding of a lab. Okay. Today, it's not very common for research labs to actually go, and there are a few examples, but research labs to go to the point where they generate something that is essential to a standard. But if they do, they, you know, financially speaking, they help their institute a lot. There are a few canonical examples of this. The turbo codes in 1993, which were patented, I guess, in around 1991. At the time, it was Lte Bretagne not in Rennes, in Brest, Berrou and Glavieux. When they developed the turbo codes, very quickly that was patented by France Telecom, or in collaboration with France Telecom, and you know, for a very long time these were exploited in both 3G and 4G. To a similar extent, the more recent polar codes that were developed at Bilkent, and then they were extended later by other researchers around the world. These found their way also into the recent 5G standard, although to a lesser extent than what they tried to get in. But I think they were less good at managing their intellectual property in comparison to the original developers of the turbo codes. And I think you could say the same thing about some of the academics that were involved in the MPEG source codec standardization. I think there must be some people in this community that are still loosely involved in MPEG. That's another one where academics actually did get involved, and quite successfully. I think really the thing here to avoid is publishing great ideas and having them stolen, and later finding them slightly modified in patents and in standards. It's a very bad feeling, and that kind of thing we should be a little bit more careful with as academics. Right, so that's really my 2 cents of why I think that some academics should get involved in these kind of things. Now, the question is how. And that's why I said 3GPP is a good example, because the 3GPP, the standardization, they have lots of possibilities for academic contributions. In fact, they have, this is just a small list here of studies that are going on. You can see these are all somehow related to signal processing. In fact, these are a bit late. Okay, and that's my next message here in a second. And what's interesting is these are very similar to research publications, but the spirit is a little bit less academic. They are still studies. They are proposed, and they get into documents of the 3GPP. But what's interesting is that you can actually derive these studies from results that you have in a research publication. But the key thing is these studies, and if there are publications, they have to have patents behind them. Otherwise, they're not valuable for the standards. Right, so it's actually not that different from what we do. Just the spirit is a little bit different. I've listed here, I'm going to skip over. These are the areas that I think, from the perspective of signal processing, in the next phase of standardization in 3GPP, where academics could play a role. Okay, you can see there's a lot here in signal processing and positioning. There are 2 aspects here in positioning. That's very signal processing heavy. The signaling strategies necessary to achieve this are definitely something that a community like this could contribute to. You know, and what I think is interesting too now in the context of 3GPP, I think they're very open to bringing in more academic groups to contribute to the standards process. There are a couple examples in Europe. Fraunhofer is quite active now inside of 3GPP. In Asia too, in Korea, in Taiwan, to a lesser extent in China too, they're also quite active in 3GPP. So there is room to do this if we want. Okay, I'm gonna skip that. What's important is really the timing. So if anybody follows a little bit the way 3GPP works, they have different releases of the standard. So the 5G system that's coming out now is this so-called release 15. They're finishing the standardization now of this release 16, which will come out maybe in a couple of years. And they're going to start working now on the so-called release 17. Today on your phones you have 4G+. This will be 5G+. So it's quite a few years down the road. And this is where there's all of those subjects that I listed are going to be studied or proposed. What's interesting is the timing here. There's a window of approximately, well, let's say 1.5 to 2 years, where you can propose new ideas to get them into the standard. And you know that's you have to follow this. It's not like publishing papers in conferences or journals where you have a bit of leeway. Here you have to get it in this time. Right? So that's the challenge. So timing is really a crucial element in this. I think I'll skip that too. So how can we make this a little bit simpler for a community to get involved, for an academic community to get involved? One of the ways is really to look at the models that are coming from open source, right? Because that's the way computer science people get, academics included, get their ideas into next generation internet type systems or different types of protocols. They go through open source communities. To a certain extent they are exploited as well, but they usually get some sort of funding from the industries that are behind the communities. So what is really an open source model? It's a means to share an implementation openly. Okay, so again, very, very classical examples are the Linux kernel or the GNU libraries that we always use. Anybody that's doing any sort of mathematical numerical processing is on a Unix system is invariably using the GNU lib somehow underneath. And this is usually coupled with a community. And there could be 2 types of communities. You can have a user community always, if you have software people are using it. But you could also have a developer or a contributor community. And this is not always the case, where you actually have developers that contribute to the software. So it's a little bit like a standard, but the collaboration on the code or the documentation is really related to the implementation. So it's fundamentally different than a standard, but the methodology is not that different from a standard. Now, what's important is if there's a community, then there are also licenses and agreements. Because if you have people that are contributing, just like a scientific community, you have your agreements on how papers are to be judged and published. It's the same thing. And this is very critical to the collaboration model. And it defines the use of the implementation, and it defines a legal framework so that contributors feel safe in this community. And that is absolutely critical. Now, why is this interesting? Because this is a model that you can use for prototyping. As researchers, you know, you see it popping up in all the conferences now. They have demo sessions because, you know, the demos, they speak a lot about an idea or potentially a patent if you're a company. Companies like Qualcomm and Ericsson are masters at putting together demos to showcase their intellectual property. Same thing, as researchers, we put together demos so that we could show our ideas. It's a very valuable technique. Now, the demos are even more pertinent if you can show some form of interoperability with industrial systems. Because then your audience is beyond the scientific community, it goes into the industrial community as well. Now, if you're not an Ericsson or a Nokia, today there are several open source solutions so that you can play around with 4G and 5G type systems, so implement the signal processing algorithms that you want, and protocols. And there are basically two. There's one that I'll describe a bit more, open air interface, and another one called SRS-LTE. And interestingly enough, these are two European communities. Okay, and they're used all over the world, both of them. What's interesting too is even if you are an Ericsson or a Nokia, these tools are still pertinent. Why? Because Ericsson and Nokia, they have research divisions. And it's very hard for the research divisions to use the commercial equipment to actually do any form of research, because it's too hard to get into the commercial equipment. So they actually use these kind of combination of open source techniques with laboratory equipment. So that's quite interesting. Now, but the main problem here, if you are an academic or even an industrial, is that when you're in the open source community, if you use traditional open source licenses, which is the case of the Linux kernel or anything like that, and you have patents, you give away your patents. So if you implement your fancy signal processing technique, your turbocode or whatever, and you don't, your patents are not protected. So it actually kills them. So you have to be very careful with that. So typically, these kind of traditional open source licenses are not good. That's why in our community, we proposed a different license, which is actually very friendly to the 3GPP type standards. So it allows people even that have intellectual property to be part of a community. And that's the way that you can get industry and academia to actually work together on a community-based approach. And it's really all in the licensing. Right, so I'll skip that because, so for me, there are really two major challenges. How you can have an open source community that works next to the 3GPP in a harmonious way. And you know, there are a couple of instances of that. And I think that the license that we propose will allow people to do that. Okay, so that is the major challenge. How you can coordinate the community with the standardization body. And then, for me, the major technical challenges in all of this is really related to this community here. What methodologies are there today for community-based development of real-time signal processing? There are no real methodologies for this. Okay, and that's part of our experiment here, is developing the methodology so as a community we can build a signal processing type application. And the reasons basically is because digital signal processing software is complex. It's much more complex than just basic open source type projects that you have out there. The algorithms are inherently complex. They're both complex from a description point of view, and their computational optimization is extremely complex. Okay? And generally speaking, we're bridging two communities together, computer scientists and digital signal processors and communications people. And that's a very challenging thing to do, because there are different ways of thinking. And of course, the other challenge is that you have interaction with hardware, and you have to be able to test with commercial devices that work with signals. So these are inherently difficult things to do in a community development. It's hard enough to do it in your own lab. Doing this now in a community with people pushing software into the system all the time is a major challenge. Okay, so how did this all lead up to Open Air Interface? Well, basically, Open Air Interface was an open prototyping activity. It started around 1997 in the 3G era. That's when we were learning what there was to do. And essentially, the initial idea was to allow DSP and communications people, in particular researchers, to experiment with real-time hardware. That was the objective. Today, it's quite a common thing. I think most of the labs in your institutes all have some activity where you're working with real-time radio hardware, or sometimes not strictly speaking real-time, but real-time signals in any case. And we were doing this to experiment in array processing, things like cross-layer scheduling, MIMO FDM receivers, mesh and relay topologies. We worked with some of the people in the room today on some of these areas in the past. And what we realized also is that we had to aim at end-to-end integration in order to test applications, because that was the way that we could start talking to the bigger companies and make our voice heard a little bit in their communities. Also, create synergy with networking communities, right? Addition of higher layer core network functions, and more modern software methodologies. That was the key thing. After all of this, then we started having partial 4G compliance, and we were able to interoperate with commercial devices. And that's actually what changed everything in this, because then we got major industry really interested, in particular a couple of companies. And the target was to have a reference implementation for 4G so that labs could do research. Okay. Then we founded an instrument called the Open Air Interface Software Alliance, and we drafted our own license to address the issues that I spoke about before. And now, basically, we're at the point where we have a partial 5G implementation, which is standard compliant. What's interesting is we gained about 2 years, because at the time of 4G, we were about 2 years behind commercial systems. Everybody was already using the 4G phones. Here, we're almost in line with the commercial systems, right? So the methodologies we put in place got us to the point where we could put out the software almost at the same time as the big players, just for experimentation, not for commercial networks. There are also network deployments for research, and if I have time, I'll talk about one or two, and some embryonic commercial use cases. We have some industry partners that are trying to find commercial use case for the software generated by this community, which is very interesting. The other interesting aspect is the evolution towards cloud-based radio signal processing. So before, the signal processing was basically a standalone device. Now this is all going into a cloud-based approach. So basically, it's the same as any Amazon or Google cloud, but it's running real-time signal processing algorithms. So that is actually also interesting, because it's related to what I said before about the mixing of two communities, the computer science communities and the signal processing and comms communities. That's what resulted in all of this here. So what is this community? In France, it has actually a judicial structure called a fonds de dotation. What that means, in English, that's an endowment fund. So basically, we set up a fund where members of the community, in particular the industry members, can fund the community so that the community can stay healthy. Right? It's a little bit different than research funding. It's not quite the same thing. And we have, a good number of major industry helping us here, and also some other players that are part of the community. The companies and the labs that I've listed here, these are all active contributors to the software. So this is quite interesting because some of these are very, very big companies. To see a company like Nokia or Fujitsu contributing to the software that came out of a university lab, that's quite nice. And they're really contributing in the sense of making it something that is much more usable by a much larger audience, which is great because it takes a lot of the effort out of the university lab and brings it into the sphere of the industries. You can see other big companies that are using it too. Facebook, during the coffee break, if somebody wants to understand what that is, it's very interesting. And these companies, they provide us some amount of donation, monetary donations, and really what is there is to maintain an engineering support team. So this is something that is outside of the lab now. There's an engineering support team there for the software, so that the community can use it. Labs like your labs can use it in much more confidence because there's a team that's supporting it. And so there are engineers there that is supporting it. They're also there to maintain the community and to do things like industry relations that the research lab should not be doing. Okay, that's completely offloaded to this structure. With this, industry is more comfortable and researchers focus on features and architecture enhancements is what we should be doing as researchers. Okay, so that's in a nutshell what this community really is. I'll skip that out of interest. Now, this is maybe interesting for people in the audience. This is the research or experimentation landscape in Europe for 5G experimental networks. Maybe some of you involved in some of these projects, but the European Commission has put in a lot of money in the last few years to establish experimental sites. And there are basically 3 projects that federate all of these sites across Europe. In a very quick summary, what's a bit unfortunate is that the European Commission, they put a lot of funding for so-called pre-commercial experimental networks. So these are networks that are running on top of Ericsson and Nokia type equipment, and they put very little money in, let's say, academic platforms, but they did put some money in there, and thankfully in France we were quite lucky actually, where you see open source solutions, such as the 2 that I mentioned, Open Air Interface Hours, and the other one from Ireland, and some other American solutions for the networking components, which allows people to build experimental, deployable outdoor networks. Okay? And with this, you can test a lot of the lower layer components that we're all interested in a community like this one. So this is really the way the European Commission decided to divide things. I'm not so sure there's a factor 4 here, but in any case, there's a big difference in the amount of funding that we're given. This is an example of the research infrastructure that was put in place in France. Okay, each of the different countries has something similar. In France, it's a bit more distributed than in the other countries. It's all managed by our national operator, Orange, and there are different types of sites. You can see one here that I'll describe very quickly at Eurocom, which is a site that is running Open Air Interface, among other technologies. There's another one in Brittany, in a partner institute called BCOM, that is also running Open Air Interface. And Orange themselves in their sites are running Open Air Interface. So what's interesting in this is that from the research perspective, even the operator is promoting the use of the open source community tools. They also have some pre-commercial Nokia-based equipment, of course, because that is what they're interested in deploying for their commercial services. But they do want to promote the idea of these types of communities that are part academia, part industry. And in fact, even Nokia, they could have put they are also contributing in the context of these things. And so this is a fairly complicated countrywide infrastructure that has some of these community-based tools that are being developed. I will skip that too. So just if I quickly talk a little bit about our site, and then maybe I can stop for questions. This is an example of how you can deploy these solutions for field operations. Right? So we asked the local regulator in France for frequency licenses. We have several. We have some that are there for 4G and some that are there for 5G. Right? So this is really an experimental playground for the community. When the community is going to push software into open air interface and some of the other tools that are in the infrastructure, they will get tested on a live network. Okay, that is something that doesn't exist today in the context of radio systems. It does exist in computing systems, but not in radio systems. So that is also a big challenge, how to get the loop from the community into a deployed network. And the actual physical infrastructure looks a little bit like this. It's a collection of fairly standard IT servers and switches connected to optical fiber to different radio units, and interconnection to the internet. Okay, so this is, in my opinion, a very modern signal processing computing engine. Okay, it's just racks of servers. It basically looks, these two racks comprise the network. Right, so you condense all of these radio functions into generic servers. This is quite different than the previous generation of equipment that you would get from a major vendor like Nokia or Ericsson. But if you were to look at the equipment from Nokia and Ericsson today, it doesn't look very different than this either. There are some more specialized devices, but you can remove the Dell logo here and put a Nokia logo, but behind it, it's still the same machines. Right, so that's also important for us from the perspective of the community that's working in signal processing, especially if you're interested in the implementation aspects. Today, it's not that different from standard algorithms on PCs. Okay? And that's something we've been trying to promote for 20 years now. But today, it is more or less a reality, even in industry. Just in terms of pictures, this is what it looks like in Sophia Antipolis. So we have basically one sector around our building. You can see here these are the 5G antennas actually. This is a 16-element array. Okay, so this the 16-way beamforming towards 5G terminals. It's still not completely up and running, but within the next 6 months, this is fully operational. Right, so the key thing now is how to get people like this community that want to contribute algorithms to push them into the software, and then they get tested on these outdoor networks. I think it's interesting from a research perspective how to get to that point, and that's the next thing. So if I try and conclude here, and maybe there'll be some time for some questions. What we've been trying to do is find the means to allow academic, or at least nonprofit research institutes, to be a direct part of the 3GPP process. Okay, that we're trying to put that in place. We're not there yet, but we're trying to put it in place, and not just a source, the classical source of ideas for the patent holders. Okay, personally, I think they've been benefiting from us far too long. Okay? And this is trying to take some of take some of the piece back. And to be quite honest, some of the interested players are pushing us to go and do this. Okay. And we will experiment with that at EURCOM over the next couple of years to see if it is a feasible thing or not. We are also interested in learning from industry partners on how to harness the commercial impact from our results. Okay, I can imagine that a lot of labs are not so interested in that, but there are some labs that are interested in that. In order to guarantee the sufficient funds so that we can do our research. It's harder and harder to get funds from governments today. We should be able to generate them to a certain extent ourselves. And also to understand some of the technical legal aspects when working in a community-based approach. I strongly believe that the community-based approach will allow us to have more impact in industry. But we still have to understand some of the legal issues because it's not simple. And industry can help us with this, and they are helping us with this. And I think finally, we need to get a better understanding of using modern software methodologies number one for implementing the signal processing systems. We still don't understand how to do that the most efficient way possible. Definitely how to test the real-time signal processing systems. That is also something that is a big part of our work from a methodological standpoint. And continually how to integrate signal processing with networking protocols and applications efficiently. That's also important from a collaboration standpoint between communities. A lot of the networking communities are now playing around with some of these tools that have been put out, and they don't necessarily have a proper understanding of the signal processing components, and vice versa. Some of the signal processing groups are not as well versed in the networking component, and this is a way to bridge some of these gaps, and ultimately we'll have much better systems if these gaps are bridged. So with that, I'd like to thank everybody and be happy to take some questions if there are any.
Anybody has some questions, please? There's one. Can you go? Can you show up, maybe? Yeah. I see that.
Many thanks for exciting talk. I just wanted to ask you, you said that these sort of platforms, open source platforms, are good for research purposes. How far off they are from commercial or pre-commercial deployment? Because some of the research labs have used them as a commercial or pre-commercial deployment to do sort of community-driven cellular architecture in parts of the world. So I'm not sure whether that scales with number of users. Can they be used as a community-driven cellular infrastructure?
Okay. Well, that's a very good question. We're on that path. Okay, I mentioned that Facebook is one of the contributors here. Their objective, at least for the protocol aspects, not so much the radio aspects, is yes, to bring it up so that it could scale to small scale networks, maybe 5,000 terminals, to have the software stable enough so that it can scale to that. Another one of the industry partners, Fujitsu, is pushing the idea of using this in conjunction with their IT platforms to have what they call private LTE networks. Right? So that's where there's no operator involved, where they go and they deploy a full solution for industrial networks, Internet of Things type networks, farming, aquaculture, that sort of thing, where they could maybe in some countries get licenses to transmit without going to an operator. Those are smaller scale networks, and there are people in these communities that are targeting the use of software like this for those type of applications. For massive cellular, I don't think we're anywhere close to being able to produce an implementation to the quality of a Nokia Ericsson or Huawei, simply because of the numbers. I mean, they have their own internal communities of thousands of engineers. It's a closed community, but it's also a community, and don't think they don't use similar kind of tools, because they do, but in a closed community. And they have their own, methodologies for guaranteeing the robustness of equipment deployed on a world scale. So we're not there. But that being said, we are very interested in the methodologies that will allow, maybe not universities, but that will definitely allow smaller companies to eventually bring it to that point. And then maybe they will be they will be providers of solutions to the Nokias and Ericssons and Huaweis based on software that came from a community. That's what happened to a certain extent in the switching and routers that are part of the internet. Companies like Cisco and Juniper were masters at driving open source communities in other areas, so that they could take that and put it into their solution. 80% of their solution comes from an open source community, 20% is Cisco or Juniper. The cellular industry is not there yet, but we're working on it a little bit, and I think the difficulties that I was highlighting here, the difficulty in the guaranteeing the signal processing component, that's the hardest thing. You see, that is really the hardest part. And if we can get the methodology to the point where you can show the robustness of a community-based development, then yes.
Okay, thank you. Any more questions? Maybe a question from me. You mentioned standardization and that you can have an impact on there. But these standard bodies, they meet a couple of times a year all over the world.
More than a couple, huh?
Isn't that very expensive to follow up on this?
There was one bullet on the slide that I had to skip. I think the key idea is the following. At the beginning, you have to get the funding for this. It's not just the meetings. You actually probably would have to hire people. I mean, you have to hire people that are working now in the research lab, that are going to go to the meetings, that are going to interact with your research group that is providing ideas. And this little team is going to have to sell that in 3GPP. Obviously, you're going to need money for that, the traveling and the people. Some of the big players in 3GPP are encouraging labs and even funding them with agreements on sub-licensing any patents. But that's at least to kickstart the process. Afterwards, I believe all of us, if we're in a European project, if you have a believable standardization activity, you can get the European Commission, just as they're funding the Nokias and Ericssons and the operators to go to 3GPP, you could probably get that funding also from your European project. Mm-hmm. But you have to be credible, I think.
Yeah. Okay, any more questions? I look around. Doesn't seem to be the case. Then I would say thank you all for coming, and
thank you,
Raymond.